streaming? Ooh. Seems to indicate that I am. Okay, very good. I think I should be streaming on YouTube now. Excellent connection. Wonderful. Well, I guess I'll record this. Right, it should be recording now. All right, so this should be a nice demo for a stream on the lab YouTube channel that I created earlier this week. And maybe I'll just, work for 30 minutes to an hour on golfing some of this code that I wrote for this Snarks project. It'd be good to see afterwards if this ends up as a video on demand on the YouTube channel. Wonder if I'll be able to retitle it. Okay, but all that is in the future. So I have all of these basically in this project, there's a whole bunch of lemmas that are destined for MATLAB. And in order to get them to go to MATLAB, it's critical that they be in a nice golfed form. So I've done this already for this. I've created pull requests for this lemma and for these two lemmas. I haven't done this one yet. This one needs to be The problem with this one is that it uses the sum function, which doesn't actually ever exist in MATLAB, because whenever it exists in the form of this 2 additive. Right? What you're supposed to do is instead you're supposed to define it for prod and then use 2 additive. So this particular lemma I'm going to handle later. That leaves remaining lemmas here. Okay, so coef single x. So I wrote this lemma that says the coefficient of a polynomial, which is just a single variable. So this is the coef multivariable polynomials. Coefs are indexed by finitely supported functions over the type of variables. Yes, the type of variables can actually be infinite, which is sort of weird. But I have this fins up single, and the point is that the coefficient of the polynomial is 1 if the single exactly represents that polynomial, otherwise it's 0. And so the primary question in my mind is this something that MATLAB will even want, or are they going to say, we don't even really want this? I mean, I guess it's probable that they would want it. It's probable that they would want it. They would they might take issue to it being stimp. I'm not entirely sure about that. Okay, we also have a similar question for powers of x, which we have down here. Okay, so we can get started with golfing. I'm not actually going to make pull requests in this stream, because that would involve switching between VS Code projects, and I don't want to handle that on the stream. So I'm just gonna edit this file by itself. Okay, so one thing that I'm immediately noticing is that presumably, whenever you have 2 rewrites in a row, you can usually do this. And indeed, that works. Okay, cool. So I'm using congruence here. The point is that after I do this pair of rewrites, I'm noticing, yeah, it's very similar proof. I'm noticing that it's just because it turns into an if then else. Yeah. fills it into like this monomule thing. And the real question is, this is not simp, though it's proved by simp. Simp x monomial power. Yeah. Yeah, some way of getting all these definitions to be transparent to simp would be maybe a better solution long term. But that's neither here nor there. Okay, now we have this. Okay, so now we're getting into this sort of not very generally useful lemmas. Like basically, if I'm being honest with myself, these lemmas probably should not exist. What they should be turned into is something that makes more sense. I wonder, let me like quickly do this to like see what the lemmas are that I'm using. It's often, I mean, technically if you have terminal simps, like these simps are at the end of their sort of proof block, technically don't have to do this simp only thing, but it's sometimes easy just to like, sometimes very nice just to see what are the lemmas that are being used. It's sometimes like nice information just to like for someone perusing the code. So I think maybe there's even an argument that simp by itself should just not appear in MathLab itself, but that's sort of a design choice. Classical, not. So what's the thing? What are we proving here? If I filter, okay, yeah, sample removed, sample target. This entire file is basically building up to the like at the very end the proof of this this theorem, which was like the critical theorem for a particular thing I needed for my project. And now this is what it looks like. Okay, so maybe the first question is, can I simply rewrite AFL sum? The first question is, if I go to this like big lemma and I have all of these calls to simp, can I simply combine them without affecting the proof, the correctness of the proof? Good question. Let's go one by one and try it out. So let me do so I was doing simp rewrite before. The question is, like, at the end of the day, do I want it to be a bunch of simp rewrites or do I want it to be simp only? Simp rewrite is another one where it's nice to be in simp rewrite rather than simp only, because when it's simp rewrite, you can like click through the proof and it's much easier to read. So let me first of all, does simp rewrite affect this? It's using simp rewrite instead of the other affect the correctness of the proof. I am also noticing that it's going to take a minute or so to recompile this proof every time I do this, because it takes long. Okay, but hopefully if we I also hear that it's the case that as you reduce the number of simps, that the reason this lemma takes so long to prove, is takes several seconds to finish, is probably because I have a billion simps in it. And that's not generally good. Okay, so the question now is, what is the order in which these things have been applied? Then support if. That doesn't look like what is happening. What looks like is being applied first here is this. Of course, that is not actually what's being first. Okay, undo. What is going on here? If then else pal. So if I equals sample removed, what is this lemma? Time to click. Oh, yeah, that's the other annoying thing if we don't have it. Pal, here we go. We type pal. If P then A else B to the power C equals if P then A to the power C else B to the power C. Huh. By split ifs ruffle. Isn't this the sort of thing that's supposed to be proven by ite apply? Um, let me try and get to the MATLAB for docs. MATLAB for docs. Welcome to the documentation page. Yeah, this is it. I mean, another thing, after seeing like the very large font, I'm remembering that there was an issue. Like when I was looking at my old video that I uploaded, I wasn't happy with the visibility. Can I just like Command plus, make this slightly larger? Maybe this will make it a little bit more legible for people trying to follow along. Ite apply. Ite PFGA. Is that what's going on here? Yeah, so, no, it's actually slightly different. What's going on? Okay, so like thinking about how these, so in this theorem, function application binds on the left. So the point is that we are applying ite to f and g, and then those are two functions, and we're applying the result to a. What's happening here, though, is something slightly different. Here, what we have is a particular function. It's a little confusing because here it's a binary operator. It's the POW operator, right? But what we actually have here is something like apply ite. I wonder if there's this. Yes. F, if P then X else Y, is the same as if P then F of X else F of Y. So it's sort of, in some ways, it sort of surprised me that this theorem even exists at all. It's like, why can't I have just have done apply? Okay, but okay, let's try and memorize. Okay, if we have an if then else raised to some power, and that's the same as taking the power of the. So going back here, what is being done? Okay, when we execute this simp block, it changes just this like sub expression here. Yeah, we have if I equals sample removed, then x sample target to the d. Basically, all of this is being raised to the power k. And when we apply ite pow, it what is even going on? Shouldn't there be two to the power k's? Yes. Okay. So now we have the inner thing to the power k and the outer thing to the power k. Okay. So can we not simply do this? Simp made no progress. Okay. Well, maybe the point is I just need to comment it out and let it maybe this is one of those cases where simp includes a bunch of random lemmas that don't actually seem to do anything. But the fact that this is taking a long time to compile bodes well, because it makes me think that, yeah, okay, so this entire block was just not necessary. Okay, cool. Let's put a question mark here to make sure that simp is doing only one thing. I mean, like, what we could actually probably do is just we could delete this, add this here. Simp made no progress. And if we comment it out, colef sum is next. Okay, so that all compiles. Cool. Let's see if we can absorb the next one in. I always get nervous that my lines are being too long. I wish, this is the thing, right? So it's doing the automatic VS Code line extension. You see, it's line 251 and it's automatically wrapping, but it's putting coef sum on the same indentation level as simp rewrite, which feels like, I mean, if it were written naturally, it would be indented. So I wonder if there's a way to get that to happen. It's like a good note to self. All right, cool. Our code is compiling. And now we encounter another thing where we have mem support if any not and coef cmol. So like pattern matching, doing literally nothing else than pattern matching from the last time. What happens if we do this and then comment this out? Okay, the next thing is an unfold. Usually unfolds are not necessary. Oh, apparently it is necessary here. That's interesting. Often like unfold statements for whatever reason don't affect the, I think this has something to do with like reflection. It's like they get unfolded anyway automatically by many tactics. Okay, so what happens if I do this? Now I tell you I don't need that. I'm just going to compile for a while. Yep, okay, still compiling. Let's try and absorb the next one. Need a space here. And like also important is to do the question mark to see if anything of interest is happening. Basically, the way that like this large sequence of simps arises is that I'm just like desperately trying to prove something, and so I'm like basically one that calls simp after every. That should be like a mode. It should be possible to just there should be like a tactic, like simp tactic mode, where like every time you apply a tactic, you just immediately apply simp, automatically apply simp for you immediately afterwards. That's something that should be done. All right. Like, for example, I feel like the ASOP developers and there's various people who are involved in like automatic theorem proving. It's like, oh, one way we can augment our automatic theorem prover is just to have it literally apply simp after every step it does, because so that's like another sort of support, evidence in support of that. Okay, well, I'm seeing mem support if again. And last time this happened, it was possible to just do this. So let's try that. Ooh, we get a bug. Okay. So apparently this was critical. We just need to figure out what was making, what were the like simp calls that were making it necessary. So if I do this, what is actually happening? Finset.filter underscore eq prime. What is this function? Filter a, yes, s.filter of an equality. Yeah, okay, so if I filter an equality, that's the same as it's either the singleton or an empty set, depending on whether it's in the set. So this seems like a case in which like membership of support actually might be critical. So is it indeed the case that the filter Is this the first lemma we apply? That's what I sort of want to know. Uh-oh, RPC error. File changed. Yeah, I do sometimes get this error, but it usually resolves itself. Okay, cool. So that makes sense. And can we now delete this, presumably? Like the thing is, it's now going to proceed to want to apply a mem support if or something. I wonder if mem support, and then there's a whole bunch of weird logic stuff, which is usually synth made no progress with that. Okay, interesting. What is happening next? I feel like there was some discussion. Well, this is actually interesting. I'm looking at the stream now and I'm seeing that it's still on the Firefox. Huh. It's not. Oh, maybe it's just lagging behind. Let me can I, yeah, I see. The view of the stream that I'm seeing in my one window is just lagging behind by like 10 minutes. The actual stream that I have is lagging behind real time by a lot. That's fine. That's just some processing. Okay, I'm just gonna minimize that window then. Okay, so continuing on. Yeah, the question is, what happens now? Okay, so the thing that happened here is that we changed this to if sample removed in support. Sample only. Maybe if then else not is something that's happening. Sample removed is in x.support. Sorry, we have two different mem support ifs here. That's confusing. What happens if I do this? I think simp rewrite is nice in that it'll fail if any one of the individual things fails. Okay, cool. So now can I delete this? Yeah, it looks like I can delete it. Very nice. Okay. And the question is, what happens subsequent to that? If x sample removed and not equal to 0, can I do like a rewrite now, I wonder? Yeah, I mean, it would be very cool if all the simp onlys would just turn into simp rewrites. The thing is, I do sometimes get pushback from the from people who say that will hurt performance. Which I mean, like, yes, it will hurt performance, but it will also increase readability. What is happening now? Not unique. Okay, so what happens now? Yeah, okay, I think I'm being able to parse now what's happening next. Next will be this, and after that will be etin not, and presumably after that will be am I wrong? Okay, this is acceptable. Let's combine the simp rewrites here. I wish is it visible? I wish that like whether or not it's simp was visible from a mouse over. And then support. So what is happening? X sample removed equals 0. So we have not X sample removed. Like, is it not? Well, yes, that seems clear that I can apply that. Did I not try applying that just now? Am I crazy? Okay, is the issue that it's just not doing anything anymore? And yeah, okay. Okay, like I have this note to myself that it doesn't work without the argument. Does it make sense to me that it doesn't work without the argument? I guess it's not simple lemma. Maybe the point is that it's too this. Yeah, like okay, what does this next simple block do? Okay, it rewrites the whole thing, but what does it do in particular is the question. Yeah. Presumably just outputs the same thing. Yeah, like show me the message. Yeah, all those things. It's like prod empty is probably something that I can simplify with. There needs to be like a script that does this sort of silly golfing stuff for the user. Okay, like now what happens if I sim question mark? Still tells me that it's about to do everything. Before, after. Prod, finset.prod singleton can be applied here. And support F. Is there etamol? What is etamol? Got to figure out what. So that's another annoying thing. It has to like compile the whole proof before it can. Yeah, so this is very similar to etab pow. Okay. So is it doing? What's it doing? Looks like it's doing etamol now. So let's try this. Small. And then presumably I can do like 1 mole. And try this. So made no progress. Now we'll just delete it. All right, cool. Let's try to absorb these. The fact that like it's a simp followed directly by another simp like sort of suggests to me that I can probably just fold all 3 of these in as well. Need to question mark these. Might as well, right? Yeah, I sort of wonder why that was not simp tagged. Because it was definitely the case here that I was like if it had just been simp tagged, it would have saved me time. Okay. Well, I think I've done enough for one day in terms of this. This was mainly just a test to see if I could stream on YouTube, and it looks like I succeeded in that. So I'm just gonna cut it off here now that I'm at about 30 minutes.